at the beginning of the year when we were covering geometry basics, we talked about what a parallel line was. And we also talked about angle relationships, but we really didn't talk about the two of them together. What we'll see today is that parallel lines do have several angle relationships in common, and we'll be able to define those and understand them a lot better by the end of this class. So remember, parallel lines are defined as always the same distance apart, called equidistant, and they never meet. So we have two examples here, the red line and the blue line. So these are parallel. They're the same distance apart all the way across, and they never meet. If they kept on going forever, they would not touch or intersect. Same thing here. We've got a red line and a blue line. They are parallel. They're the same distance apart all the way across, and they will never meet. We have our little cheesy joke right here. Parallel lines have so much in common, it's a shame they'll never meet. So, when a parallel line gets crossed by another line, we call that other line a transversal. So, we have two parallel lines here in orange and a red transversal. But you can see from this example, many of these angles are the same. We have an angle measure here of 118 degrees in the top left, and 62 degrees in the top right. But you notice these angles repeat. Our vertical angles are of course equal, and you notice 118 plus 62 is 180. So the side-by-side angles are also supplementary. Now, if we look at the set of angles down here, it's identical to this top one. The pattern repeats. So to help us keep track of which angles are congruent or equal, and which ones are supplementary or add to 180, we do what we call star boxing the angles. So I always start in the top left, and it really doesn't matter where you start as long as you're consistent, but I always start in the top left. So I start here and I put a star, and then I'll go around in a circle, kind of like a wheel shape. So I star, and then I go to the next angle and I put a box. Then I go to the next one in my circle and I put a star, and the next one in the circle and I put a box. That completes this circle. So I go to the next one and I start on the upper left of this set of angles just like I did here. And I have to put a star right there. So I'm repeating the same pattern with the bottom sets of angles that I did at the top. Star, box, star, box. So you notice here, all of my stars are 118 degrees. All of my boxes are 62 degrees. So this is going to help us to define which ones are equal and which are supplementary. Now, we're going to practice star boxing. So I want you guys to bring up the PowerPoint template, and I want you to practice star boxing. So you're going to hit on your PowerPoint. You're going to be on this page. You're going to hit review and start inking. So I'm going to start here. I'm going to show you with this one. We've got two parallel lines in our transversal. I'm going to start at the top left. I always start in the upper left, and I'm going to draw a star. I'm going to go to the next one and I'm going to draw a box. And then the next one, a star. And notice I'm going in a circular pattern here, so I have to go over here to the left and draw another box. So I've completed this circle. So now I'm going to go down to the next set of angles, and I'm going to start star boxing here too. So I still want to start in the upper left with a star, and then I'm going to go in the same circular pattern, star, box, star, box. And you notice here, I don't have a star and a box. I don't have a star and a star beside each other at all. I don't have a box next to a box. They have to alternate. So if you wind up with two stars or two boxes side by side, then you know that somewhere along the way, you got tripped up a little bit. So we need to go back and try it again. So what I want you guys to do is pause the video right here. I want you to star box this one just like I did it, and then try the same thing with this one. And I'll do the first one with you. I'm going to start again upper left with a star. I'm going to complete my circle, and then I'm going to do the same pattern over here. So press pause right now, practice on your PowerPoint, and then we will check our answers together. All right, we should have our stars and boxes here, and yours should look something like this for the second one. Star box, star box. We repeat over here, star, box, star, box. Remember, we went in a circular pattern here, kind of like a wheel all the way around, and we don't have any stars together, we don't have any boxes together. They are alternating, which is exactly how it should be. Now, if you started with a box, that's okay, as long as you have them alternating and not side by side. All right, so let's try example 1. Go ahead and star box on your paper, pause, or on your PowerPoint, pause the video, and once you've got it star boxed, we'll look at the rest. All right, so we star box. We went in a circle, and then we started on the other set of angles in a circle. And that helps us decide which ones are the same, which ones are supplementary. So here we have 3 equations. We have star is congruent to star, or star equals star. Box is congruent to box. So our measures of our angles that are boxes will be equal to all the other boxes. And then if I add a star and a box together, it equals 180, which remember that means supplementary. So I can take any 2 angles here and I can figure out, if I have one measure, I can figure out what the rest are. So I see that I have a star that's 87 degrees, which means that star is going to equal 87 degrees. And for every star, I can mark that as 87 degrees. So angle 3 is 87 degrees. Angle 5 is 87 degrees. Angle 7 is 87 degrees. Now, I need to know what the box is. I don't have that, but I can figure it out. I know that star plus box equals 180. So I'm going to fill in what I know. I know the star is 87. The box I don't know, so I'm going to put X equals 180. So I can do a couple of different things here. I can either use Desmos and type in the whole thing and find my answer that way. Or some people will just take 180 and subtract 87. And when you do that, you get back 93. So either way you do it, you get back that X equals 93. Now, what I want to do, I know that's the box. So my box is equal to 93 degrees. So wherever I see a box at 2, 4, 6, and 8, I can write in 93 degrees. All right, for example 2, we are going to circle the box to choose the sets of angles we want to select. We must select all correct sets of angles. We want to see each pair of angles that is supplementary. So the first thing I'm going to do is I'm going to star box. Star, box, star, box. Start again in the upper left. Star, box, star, box. All right, so for each pair of angles that is supplementary. So remember, supplementary means they add to 180 degrees. So if I think back to my angle relationships here, my star equals star, box equals box, and star plus box equals 180, if they have to add to 180, then the only one I can use here is the star and a box. So I'm looking for one star and one box in each angle pair. Now, if it said identify angles that were congruent, I would have to have 2 of the same. Since we want supplementary, we want one star and one box. So if I look at angle 1, here it's a star, and angle 5 is a star. So that's not one of each. I'm going to keep going. 1 is a star. 7 is a box. Star plus box equals 180. That means supplementary. So I'm going to circle that pair of angles. Now, angle 3 is a star. Angle 6 is a box. Star plus box equals 180. That's supplementary. I'm going to circle that. Angle 2 is a box. Angle 7 is a box. I have two boxes. They're equal, they're congruent, they're not supplementary. I move on to my next one. Angle 1 is a star. Angle 8 is a star. And a star equals star. They're the same. They're not supplementary. So I've answered that question. All right, so here we go. We've got some expressions here. This one looks a little harder than some of the others, but that's okay. If you remember back to our angle relationships, when we had expressions for angle measures, then we could use those angle relationships to solve for what x is. So that's what we're going to do right here. The first thing I have to do, though, it tells me the DC and EG are parallel. I have the two angle measures here. So the first thing I have to do is star box. So start at the upper left, star, box, star, box. Repeat for the next set of angles, star, box, star, box. Now, where I have DTR here, DTR stands for determine the relationship, which means I want to see out of these, which one do I have? Do I have two stars? Do I have two boxes? Do they add up to 180? So determine the relationship means we decide, are they the same? Star equals star or box equals box? Or do they add to 180? Star plus box equals 180. If I look here, I have a box and a box. So the only one of these I can use is box equals box. So that's determining the relationship. Next, I need to write out the equation. So I have box equals box. And when I write that out, I'm going to replace one box with 4x minus 18. And if I see parentheses, I use parentheses. So that equals box. So I put my other box here, 3x plus 12 in parentheses. Now, I've got my equation written out, so I can use my calculator or Desmos to solve. So when I bring up Desmos, I type in my equation just like I wrote it out on my paper, and it gives me my graph. I can click on the x-intercept here, and that gives me 30, which means that x is 30. Now, our last step here, we reread the question. Are we done? So this says, what is the value of x? Well, it's asking for x, and I found x, which means yes, I'm finished. So I'm going to circle my answer. X is 30, and I'm finished. All right, let's try another one. So we are given that A and B are parallel. It says find the value of x. So the first thing we're going to do, because A and B are parallel, we're going to star box. Go ahead and pause the video and star box on your PowerPoint. When you're done, hit play and we'll pick up from there. All right, so you should have star box the angles on your PowerPoint. Star box, star box, star box, star box. So of star box, the next thing, I'm going to DTR, determine the relationship. And remember, that means we figure out, do we have two stars that are the same, two boxes that are the same, or do we have one star and one box that add up to 180? And if I look here, I have a box that's 93 degrees, and I have a star that is 10x minus 3 degrees. So I have star and a box. So star plus box equals 180. Next, I'm going to write out my equation. So I'm going to start by writing out star plus box equals 180. First, I'm going to replace my star with the star, which is 10x minus 3. And it's plus box, so plus my box, that's 93, equals 180. Now, I can plug that into Desmos. But first, see, we are using our calculator to solve. So our calculator in this case is Desmos. We're going to bring up Desmos, plug that in, and solve for x. So I bring up Desmos in a tab, and I type out here my equation just like I wrote it on my paper. 10x minus 3 in parentheses plus 93 equals 180. I go over to the line that appears on my screen, and I'm going to click on the x-intercept, and I see that x is 9. So I used my calculator to solve it. I found x was 9. Last step, reread the question, are you done? So given A is parallel to B, find the value of x. Well, I did. I know what x is, so yes, I'm finished. X equals 9, and I finished that problem. Now, here we have one more example. Since what is the measure of angle MKR? Well, I see that I've got the arrows here indicating these two are parallel. So the first thing I'm going to do is star box, press pause, star box in your PowerPoint, and then we'll pick up from there. All right, so you should have star boxed your paper or your PowerPoint. Star box, star box, star box, star box. All right, next, DTR, determine the relationship. Meaning, I want to know, do I have 2 stars, 2 boxes, or one of each? So are they the same or are they supplementary? So I'm going to circle what I got. I have a box and a box. So the only thing I can use here is box equals box. Now, I found the relationship. Next, I'm going to write out the equation. So the equation, we're using box equals box. So I replace the value of one box with 18x minus 1 in parentheses, and the other box with 16x plus 13 in parentheses. Now that my equation is written, I can use my calculator to solve, in this case, Desmos. So I'm going to bring up Desmos in my browser. I'm going to type out my whole equation in the box. So 18x minus 1 in parentheses equals 16x plus 13 in parentheses. I'm going to find my line here, and I'm going to click on the x-intercept. The x value is 7, so I know that x equals 7. So I've used Desmos to solve the equation, and I have the answer for x. Now, last step, reread the question. Are you done? What is the measure of angle MKR? Well, MKR is this angle here, 18x minus 1. So, measure of angle MKR, it's not asking for x, so no, I am not done. So I go from M to K to R. That's the angle I'm looking for. So, angle MKR is going to be 18x minus 1 in parentheses. So I need to plug in my value of x in place of x here. So I know the measure of angle MKR is going to equal 18 times, instead of x, I put 7 in parentheses, minus 1. So what I can do is I can bring Desmos back up. I can delete out what I have written here. In this case, I can actually delete out my right side because I need 18x minus 1, but instead of x, I'm going to delete that out, and then I'm going to put 7 in parentheses. And you notice it gives me my answer right here at the bottom, 125. So now that I have that, I can circle my answer on my paper, and I'm finished. All right, guys. We're going to do some guided practice today along with some harder examples. So let's get ready and we'll do that together.